For years, German engineers poured faith, steel, and millions of tons of cement into bunkers they believed could outlast anything the Allies could throw at them. 6 feet of reinforced concrete, overhead cover rated to survive direct hits from ordinary heavy guns. Then, in the winter of 1944, something new began to speak across the battlefields of Italy and Western Europe. Its voice was not the rolling drumfire of normal artillery, but a single, thunderous blow that arrived without warning and erased entire strongpoints in an instant. Bunkers did not crack. They simply vanished. The weapon was the American M. 240mm Howitzer. In less than 2 years, it would turn the proud concrete spine of Hitler's fortress Europe into a graveyard and convince German soldiers that no wall on earth was thick enough anymore. The morning sky over Anzio carried a strange stillness, one of those brittle Mediterranean dawns where the air felt thin, as if holding its breath. The German command posts dotting the low hills behind the beachhead had survived weeks of naval gunfire, Allied bombing runs, and the steady pounding of conventional field artillery. Nothing had shaken their confidence. Their bunkers had been built according to long-perfected engineering doctrine: reinforced concrete, steel bracings, low profiles, interlocking coverage, and carefully surveyed firing lanes. These were not improvisations, but the hardened spine of the German 14th Army's defensive network. Inside one of these posts, a junior officer pressed his eye to a periscope fixed in a steel-lined shaft. He had watched the Allies for days, American troops digging into shallow foxholes, vehicles scattering across the plain, the unending dust kicked up by supply convoys. There had been no surprises so far, nothing the German defenders hadn't faced before. But on that cold afternoon, a shockwave rolled through the hillside with a violence no one had predicted. First came a blunt, distant thud, so deep it felt rather than heard. Then the ground convulsed. Concrete trembled. Dust sifted down from ceiling joints. One officer dropped his pencil. Another instinctively reached for his helmet, even though he was underground. When the periscope steadied, the junior observer peered again toward a strong point known as Bunker Louisa. For 8 months, Louisa had anchored a line of mutually supporting fortifications, a structure built to absorb direct hits from 210mm shells without collapsing. It was the type of bunker that had given German soldiers immense confidence in their defensive doctrine. But now, nothing remained. In the observer's field of view, there was no roof, no shattered wall, no exposed rebar, just a raw, circular crater smeared across the earth like a wound still smoking from the blast. The men stationed there, 32 grenadiers of the 3rd Panzer Grenadier Division, were simply gone. No rescuing, no digging, no recovery. It looked less like a bunker had been destroyed, and more like it had been erased from existence. That single shot marked the European combat debut of the M1 240mm Howitzer. This weapon had been designed for a moment exactly like this. Unlike the big guns mounted on Allied ships, or the heavy railway guns that had thundered across Europe during earlier wars, the Black Dragon was built for battlefield mobility. It was not fast, and not convenient, but it could be dragged into position by prime movers, assembled by a 14-man crew, and made ready to fire within hours. When its barrel, 35 feet of forged steel, weighing over 23,000 pounds, was aligned on target, it existed for a single purpose: penetrate fortifications and collapse them from the inside. The shell it fired weighed 360 pounds. But raw weight alone doesn't explain what happened to Bunker Louisa. The secret lay in the weapon's combination of velocity, fuse design, and the very physics of concrete failure. The concrete-piercing projectile, designated M17, featured a hardened steel cap designed to bite through solid slabs before detonation. When the Black Dragon fired, the shell accelerated down the rifled barrel at more than 2,300 feet per second. At that speed, the cap struck reinforced concrete not like a blunt hammer, but like a drill, forcing its way in 2 to 6 feet before a delayed fuse triggered the explosion. The blast did not merely destroy the spot where it hit, it shattered the entire structure from within. Engineers would later call this phenomenon sympathetic fracturing, shock waves ricocheting through steel reinforcement, creating stress lines that caused entire bunkers to implode. Inside any German bunker chosen as a target, the sequence was always the same. A tremor, a cracking sound in the walls, a flash, then the collapse, brutal and inescapable. Survivors were rare, not because the explosion always hit directly, but because the pressure created within a confined space was lethal. Even a near miss could kill with shock or suffocation, as air was violently compressed inside the sealed chambers. What made the weapon's debut even more shocking to German observers at Anzio was the precision. Their experience against Soviet artillery had conditioned them to expect terrifying but inaccurate barrages, storms of shells that destroyed landscape but seldom hit individual bunkers. The Black Dragon was different. It did not saturate an area. It hunted a target. On January 30th, the very first operational shot fired by the 697th Field Artillery Battalion travelled roughly 13 miles before striking Louisa. The idea that an American artillery unit, positioned far beyond visual range, could land a direct hit on a single reinforced bunker defied German assumptions about Allied gunnery. Accuracy, they believed, came only from massive railway guns fixed on surveyed tracks, or from pre-registered positions known well in advance. But the Americans had brought something new, a modern fire direction center system, FDC, capable of coordinating maps, slide rules, meteorological data, observer reports, and graphical firing tables within minutes. Forward observers at Anzio, crouched behind rocks and shattered walls, watched through binoculars as German strongpoints emerged from the haze. Their CR-610 radios crackled with coordinates transmitted back to the FDC. In just 4 minutes, the Black Dragon's crew received their firing solution, adjusted elevation, set the delayed fuse, and loaded the massive shell with the aid of an integrated crane. When the howitzer recoiled from firing, the entire landscape moved. Soldiers described it as standing too close to a train when it thundered past. The concussion slapped the chest and rattled teeth. And yet, from the target's perspective miles away, the first sign of danger was often the bunker's roof buckling inward. In the German mindset, fortifications were sanctuaries, places where men could outlast bombardments, regroup, and fight on. Bunkers had always been designed to absorb horizontal impacts. The 240mm Howitzer, with its high-angle trajectories, often dropped shells near vertical onto roofs, the weakest point in many defensive structures. At Anzio, panic spread faster than the explosions themselves. Prisoner interrogations would later reveal that some German units refused to occupy bunkers after witnessing the aftermath of a Black Dragon strike. They preferred shallow trenches to the solid, seemingly safe concrete positions that had defined their doctrine since the days of the West Wall. For the Americans, the psychological reaction was almost as valuable as the physical destruction. Every time the gun crew heard the order for a new mission, they understood they were about to dismantle another position that would have required hundreds of infantrymen and likely dozens of casualties to clear by hand. The first day of operations told its own story. By nightfall, the 697th had fired multiple rounds. Each mission had been recorded with near-clinical precision. Rounds expended, bunker designation, observed effects. In mission after mission, German strongpoints that had endured countless previous attacks were reduced to rubble. What unfolded at Anzio was not merely the introduction of a new weapon, it was the unveiling of a concept the Germans had not imagined the Americans possessed: mobile, super-heavy precision firepower. As word spread along the German defensive lines, so did the fear. Fortification, warfare, a system refined over decades of doctrine and experience from the Great War, suddenly felt obsolete. A bunker was no longer a shield. It was a point of failure waiting to be identified, calculated, and obliterated by a single American shell. And this was just the beginning. The Black Dragon had announced its arrival. The Germans now understood what it could do, and what they did not yet realize was how often they would face it in the months to come. Anzio was merely the first lesson, a preview of a weapon that would follow them from Italy to Normandy, across France, and all the way to their own frontier. The age of the bunker was ending. And the M12 140mm howitzer had delivered the first blow. Long before the Black Dragon thundered across the hills of Italy, its story began in a quiet, unsettling realization inside the US Army Ordnance Department. In the late 1930s, as Europe caught fire once more, American observers studying new German fortifications returned home with a troubling message: the standard US arsenal, dominated by field guns in the 105mm and 155mm class, would not be enough against the hardened shelters taking shape along the Atlantic Wall and the fortified frontiers of Central Europe. The concrete bunkers rising across the continent were thicker, stronger, and more geometrically reinforced than anything American guns had been designed to defeat. Reports circulated with diagrams of casemates boasting walls up to 6 feet thick, overhead protection that resisted aerial fragmentation, and angled structures intended to deflect incoming rounds. Engineers who had witnessed German methods firsthand described a doctrine that treated fortification as both science and craft. Even the largest American field piece at the time, the 155mm long Tom, could damage these structures, but rarely destroy them with certainty. Fixed defenses were returning as a dominant feature of European battlefields, and the United States possessed no reliable means to breach them. By 1940, the Ordnance Department initiated a study that would quietly redefine American heavy artillery. The goal was audacious: create a mobile weapon capable of firing a projectile heavy enough to crack modern concrete fortifications, yet mobile enough to be transported by existing military vehicles rather than rail lines. This requirement alone set the project apart. Europe's super heavy weapons, German K5, railway guns, Soviet 280mm mortars, French siege pieces preserved from the Great War were immobile giants chained to fixed tracks or enormous emplacements. The United States sought something different, something that a field army could relocate as battle lines shifted. The specifications read like a challenge bordering on impossible. The new howitzer had to fire a shell weighing more than 300 pounds. It needed the range to reach targets over 14 miles away. It had to be accurate enough to strike individual fortifications rather than bombarding areas blindly. And, above all, it had to be transportable in sections across rough terrain before being assembled by a crew in the field. Responsibility for this ambitious undertaking fell to the engineers at Watervliet Arsenal in New York, a facility that had been producing heavy cannon since the early 19th century. The team began by studying the physics of large-caliber projectiles, examining how steel behaved under extreme pressure, and calculating recoil forces that threatened to tear the weapon apart if poorly managed. Through months of prototypes, adjustments, and stress tests, a form began to emerge. A long-barreled, high-angle howitzer, capable of delivering its projectile along a steep, plunging trajectory. The barrel alone became a masterpiece of industrial precision. Machined from a single forging weighing more than 60 tons, it required 72 hours of continuous boring to achieve the necessary smoothness inside the rifling. Heating, quenching, and reheating tempered the steel until the massive tube could withstand years of firing cycles. At 35 feet in length and weighing 23,000 pounds, it demanded a specialized wheeled wagon for transport, a 6-wheeled carriage designed specifically to bear its weight without warping. But the barrel was only part of the design. To bring the weapon into action required components that resembled a mechanical puzzle. A 2-part carriage allowed the gun to be disassembled for towing. A massive recoil system, buried deep within the frame, absorbed the violent backward thrust of each shot. A broad firing platform required careful leveling, often involving excavation of a recoil pit, so the rammer and breech could cycle unimpeded. The gun crew relied on an accompanying M2 crane, a piece of equipment as essential as the howitzer itself, to lift the 2 parts of each shell, the projectile and the powder charge bags. The challenge did not end with the physical construction. If the Black Dragon was to fulfill its intended purpose, it required a shell worthy of the weapon. Engineers developed two primary types of ammunition: a high-explosive projectile and a concrete-piercing round with a hardened cap, designed to penetrate fortifications before detonation. The concrete-piercing MEM-17 became the weapon's signature. It combined extreme mass with delayed fuse technology, ensuring the explosion occurred inside the target rather than at the surface. The result was an internal shattering effect that no amount of external reinforcement could reliably counter. Yet, even a perfect gun and perfect projectile could not meet the battlefield's demands without an equally formidable logistical machine behind them. A battalion equipped with the new howitzers required more than just ammunition. Each firing position demanded dozens of vehicles: prime movers to tow the guns, two main loads, maintenance trucks, generator trailers, ammunition carriers, and specialized cranes. Fuel consumption soared, spare parts became indispensable, and crews needed rigorous training to operate under battlefield pressure. By the time the first pilot models rolled out in November 1942, Watervliet had become a symphony of noise and motion. Sparks flew from machining floors. Furnaces glowed across the assembly halls. Women made up more than a third of the workforce, highly skilled machinists who handled the precise shaping of rotating bands, breech mechanisms, and fuse housings. Production accelerated rapidly, climbing from 6 pilot units to a monthly average of 13 guns during peak output in 1944. America had succeeded in building the heaviest mobile artillery piece of the war, but this new weapon still needed to be integrated into a doctrine that would allow its destructive potential to be fully realized. To achieve this, the Army refined its artillery command structures. Fire direction centers evolved into highly coordinated hubs that transformed requests from forward observers into firing solutions with remarkable speed. Meteorological teams supplied wind conditions, humidity, and atmospheric pressure. Survey crews measured terrain with precision that rivaled civil engineering projects. Everything centered around a single goal: ensure that the first round fired at a bunker would destroy it. Speed, accuracy, and synchronization mattered. A super-heavy shell was too valuable to waste. Each shot demanded calculations involving projectile drift, barrel wear, powder temperature, and overhead clearance. Meanwhile, gunners across the Atlantic trained under increasingly realistic conditions. They practiced assembling the massive weapon under simulated battlefield chaos, forcing themselves to coordinate quickly, even as noise, smoke, and fatigue worked against them. Ammunition handlers learned to move 360-pound rounds as if they were routine cargo, despite the fact that each projectile required the strength and timing of an entire team. Numbers 9 and 10 on the crew handled the crane, swinging the heavy shells into alignment, while others steadied and guided them into the breach. Over time, these crews developed an almost ritualistic rhythm. A new firing mission meant a burst of activity. Coordinates relayed from the observer, hands scrambling over elevation wheels, fuse setters adjusting dials, powder bags prepared in their specific sequence. Then came the moment of silence, just a breath before the gunner signaled and the weapon fired. The shock of the recoil rippled through the frame like a living thing. Dust kicked up. The barrel dipped, then returned to battery. The breech opened, and within 90 seconds, the crew stood ready to repeat the process. For all its power, the Black Dragon was not without limitations. It was heavy, slow to emplace, and demanding on its crews. A single relocation could consume hours of labor. The gun's weight damaged roads and forced engineer units to prepare firm ground before deployment. Ammunition stocks, once depleted, required constant resupply from transatlantic convoys, depots, and truck columns operating under pressure. But none of these drawbacks overshadowed the purpose for which the weapon had been created. American planners recognized that the coming battles across Italy, France, and Germany would not be defined solely by open maneuver. They would be shaped by fortifications, mountain bunkers, coastal casemates, reinforced towns, and concrete belts stretching across entire frontiers. Armies could not afford to halt for days while bombers, infantry, and medium artillery attempted to reduce each position. They needed a weapon that ended such fights quickly, decisively, and with minimal cost in lives. Army leadership had begun positioning heavy artillery battalions for future operations across Europe. Training intensified. Ammunition stockpiles grew, and senior commanders quietly prepared to unleash the new weapon when the moment was right. That moment arrived at Anzio. The German defenders who watched Bunker Luisa vanish did not yet know the full story of the weapon that had struck them. But back in America's factories, logistics depots, and training ranges, the Black Dragon had already completed its long journey from concept to battlefield reality. What had begun as an urgent engineering problem had become a force capable not only of destroying physical structures, but of undermining the very foundation of German defensive doctrine. The crews were ready. The ammunition was stockpiled, and Europe's most fortified lines had yet to realize that their greatest vulnerability had already begun. Its march across the continent, the arrival of the Black Dragon at the Anzio beachhead in January 1944, did not resemble the unveiling of a superweapon. There were no grand announcements, no anticipatory whispers among infantrymen, and no hint to the Germans that a new kind of artillery had taken its place behind Allied lines. The 240mm Howitzers rolled in quietly, dragged across muddy roads by prime movers, groaning under their weight, their long barrels shrouded in canvas like dormant beasts awaiting a signal. At a glance, they looked less like instruments of precision warfare and more like industrial machinery forced into a battlefield it did not belong to. But as crews assembled the guns piece by piece in shallow excavations, a transformation began. Steel girders, heavy carriages, and hydraulic components merging into a single, coherent, lethal shape. For the men preparing these weapons, Anzio was already a dangerous place. German artillery observers perched on surrounding ridges could see most Allied movements. Shells whistled overhead in irregular intervals as the enemy continued its relentless effort to contain the beachhead. Crews worked under camouflage nets and intermittent fire, relying on discipline rather than speed, knowing that a rushed assembly could cripple a weapon that demanded mathematical precision. They dug recoil pits, leveled platforms, mounted the massive barrels, and tested the traverse mechanisms inch by inch. Every sound, every clank of metal or grunt of exertion echoed through air, already tense with anticipation. The Americans understood that these guns were not simply large, they were transformational. Yet no one could predict exactly how the Germans would respond to what was coming. The Black Dragon's trial by fire at Anzio would be the moment when theory, engineering, and doctrine converged or collapsed under the pressure of real combat. The stakes could not have been higher. If the weapon failed to deliver the promised precision, the Americans would have only an unwieldy, vulnerable piece of steel in a landscape dominated by enemy artillery. If it succeeded, then the entire concept of German defensive warfare would face a reckoning. The first mission came on January 30th, targeting a German observation post perched high on the Alban Hills. Dense smoke from earlier clashes still hung across the landscape in drifting sheets, while the enemy position itself remained almost invisible to the naked eye. Forward, observers relayed coordinates through radio, static, consulting aerial photographs, and field maps as they worked to refine the target's exact location. When the Fire Direction Center completed its calculations, they passed the solution to the gun line in a set of commands precise enough to guide a strike across miles of terrain. The crew prepared the first round, a concrete-piercing M17, lifting it with the crane until the projectile hovered like a dark, heavy pendulum over the waiting breach. Hands steadied it, guiding the shell inward with practiced effort. Powder bags followed, each placed in the correct sequence to achieve the required range. As the breach closed, a moment of stillness washed over the gun pit. Smoke from nearby vehicles drifted past the camouflage net. The gun chief gave the signal. Then the Black Dragon spoke. The recoil shook the surrounding earth. Nearby crews felt the concussion in their chests. Farther ahead, Across the landscape, infantrymen crouched in their shallow defensive lines sensed a distant tremor, unaware they were witnessing the first heartbeat of a new era. The shell climbed upward in a steep arc, disappearing into the sky before gravity pulled it down toward the unsuspecting bunker below. There was no warning scream of incoming fire, no echo of multiple shots, no gradual adjustment typical of Allied artillery. 1 second the bunker stood in place, the next, a plume of dust and shattered concrete lifted into the air like a volcanic burst. When the cloud settled, the observation post had disappeared entirely. Not damaged, not cracked, erased. The shock spread quickly through Allied ranks. Soldiers accustomed to lengthy bombardments were stunned that a single shot produced such devastating results. Engineers accompanying frontline units studied the crater left behind, noting the depth of the penetration and the pulverization of reinforced concrete that should have withstood everything short of naval gunfire. The Black Dragon had proven not only its destructive potential, but also its accuracy. An accuracy that contradicted decades of experience with super-heavy guns around the world. Word spread even faster among German defenders. Prisoners captured within hours reported confusion and panic. Men described the effect of the blast as an earthquake strike, something that shook the ground for hundreds of meters and left them disoriented, even when not directly hit. Some thought the Allies had deployed a naval cannon inland. Others insisted a new form of bomb had been fielded. What unified their reports was a growing uncertainty, an unease rooted in the realization that their fortifications, the hardened backbone of their defensive lines, might no longer be safe. As the days passed, the Black Dragon continued firing. Records from the 697th Field Artillery Battalion documented bunker after bunker, struck with a precision unheard of in artillery warfare. Some required multiple rounds, but many were destroyed outright by a single impact. Allied commanders quickly recognized the value of these new guns. Instead of risking infantry assaults across minefields and interlocking lines of fire, they simply identified bunkers and fed coordinates into the American fire control system. Hours that might have been spent planning costly attacks turned into minutes of targeted bombardment. For the Germans, the psychological damage deepened. Some units attempted to reinforce their positions, adding more timber, sandbags, and internal bracing. The howitzer's delayed action fuse allowed the projectile to penetrate deep before detonating, making external reinforcement effectively meaningless. Even near misses proved deadly, as the blast waves traveled underground and fractured concrete from below. Soldiers stationed inside these bunkers began to reconsider their assumptions about safety. Reports from German war diaries reflect this growing fear. The 715th Infantry Division noted that losses from these single shells exceeded entire days of conventional bombardment. Shell shock, an expected condition in trench warfare, reappeared among troops who had previously believed themselves protected. One diary entry captured after the liberation of Rome stated grimly, "Heavy artillery we can endure. This new American gun turns our fortifications into traps." Night brought no relief. High-angle fire allowed the Americans to target reverse-slope positions hidden from direct observation. Shells dropped almost vertically, exploiting the weakest structural points of the bunkers. German engineers had designed these positions to resist direct fire, not plunging impacts. As evidence mounted, German commanders realized their doctrine had been built around an assumption that no longer held true, that reinforced concrete, properly constructed, was nearly invulnerable to field artillery. The Black Dragon shattered that belief, as surely as it shattered the bunkers themselves. Meanwhile, for the American gun crews, Anzio became the crucible that turned training into confidence. They learned to anticipate the weapon's behavior under different weather conditions, adjusting charges to compensate for humidity or temperature shifts. They tracked barrel wear carefully, a critical factor in sustaining accuracy. Their teamwork evolved into a choreography of motion, each man performing his role with almost mechanical precision, even under direct enemy fire. As the campaign continued, the Black Dragon established itself as more than a tool. It became a strategic advantage. Its presence alone forced German commanders to reconsider their positioning. Bunkers, once seen as anchors of the defense, now became liabilities. Troops left supposedly secure positions whenever spotting reports suggested American heavy artillery was active. It was a subtle yet powerful shift. Instead of defending from their strongest fortifications, German units increasingly relied on mobility, dispersing into temporary field positions that offered less protection but reduced the risk of catastrophic loss from a single shell. The shift was not lost on Allied commanders. The Americans recognized that the Black Dragon had delivered more than destructive power. It had produced a new psychological landscape. German troops were now hesitant inside fortifications, while Allied units gained the confidence to advance, knowing the deadliest strongpoints could be eliminated with carefully placed shots. Anzio demonstrated the Black Dragon's full promise. It proved that mobility did not mean fragility, that precision did not require fragile equipment, and that even the most hardened fortifications could collapse when struck by a weapon designed explicitly for that task. The Germans learned this truth the hard way. And the lesson did not end at the Italian coast. The Black Dragon's success at Anzio marked the beginning of a journey that would carry the weapon across Europe, from the monasteries of Monte Cassino to the hedgerows of Normandy, and finally to the fortified gates of Germany itself. The baptism of fire was complete. The era of invincible concrete was over. By the time spring settled over the Italian peninsula in 1944, the M1 240mm howitzer had already shifted from a curiosity to a strategic instrument. The Anzio beachhead had proven its precision, but the battles ahead would test whether a handful of super-heavy guns could influence entire operations. Italy's mountainous terrain, scarred by ancient river valleys and fortified ridges, offered the perfect proving ground. The Germans had shaped their defences around geography, pouring concrete into every fold of rock and transforming natural bottlenecks into fortress systems. At the centre of it all stood the Siegfried Line, anchored on the heights of Monte Cassino. Its stone walls, Roman foundations, and commanding view of the valley made it one of the most important defensive positions in German hands. Air bombardments shattered the monastery, but not the underlying fortifications carved into the mountainside. British, Indian, New Zealand, and American units had all tried to break through. The Germans, especially the elite paratroopers defending the heights, seemed unmovable. When the Allied command introduced super-heavy artillery into this desperate struggle, hopes rose, but skepticism remained. They were reinforced by both natural rock and human engineering, positioned where the mountain shielded them against horizontal fire. Yet the steep trajectories of the Black Dragon offered a different angle of attack, one capable of dropping shells almost vertically onto the hidden positions. The 240th Field Artillery Battalion moved into firing positions near the town of Mignano, where the valley floor opened into a natural bowl capable of absorbing the massive recoil of the Black Dragons. Crews worked through rain, fog, and the unsteady spring winds, aligning their howitzers on targets marked by forward observers clinging to precarious observation points. At these distances, every environmental factor mattered. Crews compensated for shifting temperature, calculating powder adjustments in real time. The observers directed fire through narrow slits in ruined buildings, guiding shells closer and closer to the bunkers carved into the slopes beneath the monastery. What followed would become one of the most important demonstrations of super-heavy artillery in the Italian campaign. The Black Dragons began firing on the night of May 11th, unleashing a bombardment that continued for 72 hours. Each round travelled high into the clouds before plunging down onto concrete, stone, and steel. The explosions reverberated through the valleys with a rolling thunder that shook Allied and German positions alike. Bunkers that had shrugged off countless attacks now suffered direct hits through their roofs. Observation posts that once commanded the battlefield vanished under landslides triggered by the massive impacts. British Major General Francis Tucker, whose 4th Indian Division had been mauled in earlier assaults, observed the bombardment with astonishment. For months, His troops had confronted bunkers that seemed immune to everything except a direct assault. Now, for the first time, those positions collapsed one after another. Tucher's reports emphasized the psychological impact as much as the physical results. German communication lines faltered, defensive coordination broke down, and the once stubborn paratroopers were forced to abandon positions that had formed the backbone of the Gustav Line. By the time the main Allied attack surged forward, the mountaintop defences had begun to crumble. When Monte Cassino finally fell, the Black Dragons had played a decisive role not by levelling the monastery, but by crushing the reinforced positions that anchored the entire system. The lessons learned at Anzio had matured into a doctrine. Find the bunker, calculate the strike, drop a single shell where it hurts most. The heavy guns earned a reputation that spread across the German front lines faster than official reports could track. But Italy was only one chapter. Europe's greatest fortified regions still lay ahead. When Allied forces landed in Normandy in June 1944, they encountered a different problem. The hedgerow country behind the beaches concealed reverse-slope bunkers and hardened firing positions impervious to naval gunfire. Many of these bunkers had survived the carpet bombing before Operation Cobra, protected by terrain that absorbed lateral shockwaves. The German 352nd Infantry Division, backed by experienced paratrooper units, had turned every crossroads, ridge, and orchard into a miniature fortress. Infantry assaults stalled repeatedly. Medium artillery disrupted but rarely destroyed these strongpoints. The arrival of 240mm Howitzers in late July offered the Allies a way to dislodge the defenders without sacrificing troops. The 272nd Field Artillery Battalion positioned its guns carefully, learning from the travel and recoil challenges that had slowed earlier operations. Powder bags were adjusted to account for summer heat, and crews built reinforced firing embankments in the soft Norman soil. Their first mission targeted the fortified reverse slope of Hill 122. German defenders believed the hill safe from long-range fire, its slopes absorbing most shells before they could reach the bunkers drilled into the far side. The Black Dragons, firing at steep angles, bypassed the slope entirely. Forward observers watched in disbelief as shells descended nearly vertically, striking the hillside as though dropped by an invisible hammer. After 3 rounds, the main bunker disappeared. When American infantry advanced hours later, they found only a crater and fragments of equipment scattered like scrap. The paratroopers who had defended the hill fled before the bombardment concluded, abandoning their prized position. The German command struggled to replace units shattered by weapons they could not see and could not counter. Wherever the Germans believed terrain could shield their fortifications, the Black Dragons found angles to exploit. Crossroads, ridgelines, cement-reinforced barns, and hidden machine gun nests all met the same fate. American commanders treated the guns as a scalpel, excising strongpoints that slowed movement or threatened to halt advances. Unlike massed bombardments that destroyed entire districts, these guns delivered precision that saved time, men, and materiel. As summer gave way to autumn, the campaign reached the most formidable barrier yet. This defensive system cut across the Apennine Mountains, where rugged heights, deep ravines, and fortified passes offered the Germans a chance to prolong the war. Engineers under organization, Tott, had spent a year carving bunkers into cliffsides, reinforcing passages with angled concrete walls, and constructing positions shielded from nearly every direction. High-angle artillery would be essential, and the American commanders knew their Black Dragons would again determine whether infantry could advance without catastrophic casualties. The 697th Field Artillery Battalion, veterans of Anzio and Rome, hauled their howitzers into narrow valleys beneath the Futa Pass. Soldiers struggled to maneuver the heavy weapons across mountain roads, barely wide enough for standard vehicles. Crews used bulldozers to level firing platforms and cut shallow pits into the rock-strewn ground. Meanwhile, forward observers climbed ridges under fire, relying on ropes to reach positions with clear views of the German fortifications. The mountain wind complicated their work, shifting unpredictably with each hour. Fuse settings had to be recalculated repeatedly. When the bombardment began on September 16th, the sound filled the valleys like a rolling avalanche. Shells arced over the ridgelines and plunged down onto the bunkers embedded in the reverse slopes. The explosions echoed across the mountains with a metallic ring, blasting smoke upward like geysers. German soldiers inside the fortifications felt the earth tremble before the walls buckled. Some positions collapsed entirely. Others suffered internal fractures that forced their defenders to retreat. American infantry advancing through the passes reported scenes unlike anything they had witnessed earlier in the war. Bunkers that once looked impenetrable had been split open as though struck by a gigantic chisel. Doors were blown inward. Steel reinforcement twisted into jagged spirals, and concrete blocks scattered across cliff edges. In many places, the collapse had created landslides that buried firing positions under tons of rock. German records from units defending the pass make clear how demoralizing this was. Soldiers accustomed to surviving bombardments now hesitated to occupy even the best protected positions. Each Black Dragon shell felt like a reminder that mountains and engineering alone could no longer guarantee survival. These operations revealed a new truth with brutal clarity. The Luftwaffe could command the skies. German artillery could pound Allied lines. Infantry, tanks, and machine guns could maneuver and resist. Yet none of these measures saved their fortifications once the Black Dragons came into range. The old belief that concrete is life dissolved under the weight of American firepower. The lessons of Cassino, Normandy, and the Gothic Line converged into a single, undeniable conclusion. German defences could be broken not through attrition, but through precision delivered by a weapon that refused to be constrained by terrain, doctrine, or distance. And with each shattered bunker, the psychological fracture deepened, one that no amount of engineering expertise could repair. By late 1944, the M1 240mm Howitzer had already carved its reputation into the mountains of Italy and the hedgerows of France. Yet none of those battles compared to what awaited the Allies as they approached the German border itself. Stretching from the Netherlands to Switzerland lay the west wall known to the Allies simply as the Siegfried Line, a belt of concrete, steel, and interlocking bunkers built over years to protect the heart of the Reich. Whereas Italian and French fortifications had been formidable, the Siegfried Line represented the pinnacle of German engineering and strategic imagination. Its bunkers boasted thick walls, angled embrasures, steel cupolas, and deep underground galleries. German commanders trusted these positions as immovable anchors capable of withstanding virtually anything short of naval gunfire or long-term siege. When American units first encountered the line, they found more than static defenses. They found entire defensive ecosystems built around forests, hills, and towns, fortified to serve as mutually reinforcing strongpoints. Mines, barbed wire, concrete dragons' teeth, and anti-tank ditches surrounded hardened bunkers whose firing lanes overlapped with deadly precision. The terrain itself favored the defenders. Dense woods prevented aerial reconnaissance from identifying concealed positions. Narrow roads restricted Allied armor. The weather, turning colder by the day, added another layer of difficulty. Under these conditions, conventional approaches risked heavy casualties. The 265th Field Artillery Battalion moved into positions near Aachen in September 1944. Generalship demanded speed, but the heavy guns required careful preparation. Engineers cleared space for firing pits, while crews aligned the howitzers along a series of predetermined azimuths, targeting bunkers that had resisted previous assaults. Survey teams worked through cold rain, establishing exact coordinates for firing points. Meanwhile, ammunition trucks churned through mud to deliver the massive M17 concrete-piercing projectiles, stacking them under camouflage nets in preparation for the barrage. The Germans defending this sector believed their positions safe. Command bunkers featured even greater protection, some boasting walls more than 8 feet thick. These constructions had survived storms of artillery fire throughout the war. Even Allied aircraft had struggled to damage them significantly. German war diaries from the period reflect confidence rooted in the idea that their fortifications represented an impenetrable shield. Many believed the Americans would be forced into grinding assaults, reminiscent of the Great War. On October 8th, the 265th began a systematic bombardment targeting the bunkers along the Scharnhorst Line, an extension of the Siegfried system protecting Aachen. As the first shells soared over the forest canopy, the crews held their breath. Forward observers watched through high-powered scopes from concealed positions. The impact arrived as a burst of concrete dust that rose above the treetops. Within minutes, another followed. The sequence continued until 19 of 22. Targeted bunkers lay shattered or collapsed. These results, achieved in only 6 hours, signaled a shift deeper than any local breakthrough. The destruction was so complete that infantry advancing behind the bombardment sometimes found little more than cratered ground where the bunkers had once stood. Steel doors were torn away. Entire concrete slabs flipped like discarded debris. In some cases, the structures were not merely breached, but pulverized, leaving no identifiable remnants. German soldiers inside had no opportunity to retreat. Many survivors described the sensation of the bunker shaking violently before walls caved inward, trapping or crushing the defenders. These outcomes forced German commanders to confront the reality that their defensive strategy, built around these fortifications, was no longer viable. In the Schneifel region, the 278th Field Artillery Battalion executed a similar operation. Working with V Corps, they identified 73 bunkers that had been carefully camouflaged among the trees. Over the course of several days in December, the Black Dragons dismantled these positions one by one. A pattern emerged that alarmed German engineers. The shells did not merely damage structures, they induced ground shock that propagated through soil and bedrock, even when a shell landed several meters away. The bunker's structural integrity suffered catastrophic damage. For soldiers inside these positions, the sense of security that concrete once provided had evaporated completely. Word of the weapon's effect spread across German lines. Troops manning the Siegfried Line began requesting permission to occupy temporary field positions rather than bunkers. Officers struggled to maintain discipline, as soldiers preferred exposed foxholes to reinforced shelters. This reversal of defensive logic marked one of the war's most remarkable psychological shifts, a testament to the destabilizing power of the Black Dragon. The destruction extended beyond rural fortifications. In November 1944, the 698th Field Artillery Battalion participated in reducing the fortress ring around Metz, a city that the Germans had fortified heavily, blending ancient walls with modern bunkers. The terrain surrounding the city included hills riddled with defensive structures intended to halt any advance. Using their howitzers, American artillery targeted each bunker with surgical precision. Within 2 weeks, and over 3,000 rounds fired, the fortifications collapsed, clearing the way for the capture of Metz. This achievement stunned military analysts familiar with the fortress's storied history. The industrial heartland of Germany soon faced the same fate. As the Allies advanced toward the Ruhr Valley, they encountered factories transformed into strongpoints. Steelworks, refineries, and manufacturing plants had been converted into makeshift fortresses by reinforcing existing structures with poured concrete and steel plating. The Crew Steel Works in Essen represented one of the most imposing of these ad hoc fortresses. Its thick industrial walls, designed to withstand internal pressure and heat, now doubled as defensive barriers. On April 9, 1945, Black Dragon fire targeted the facility. When the dust settled, the main structures lay in heaps of twisted metal. For German troops inside, the bombardment created unbearable shock and disorientation. The entire sections of the plant collapsed. Those who survived often surrendered immediately. The speed with which the Black Dragons dismantled these industrial fortresses reinforced the impression that nothing built by human hands could withstand their force. Psychological effects multiplied. German prisoners from units along the Rhine crossings and within the Ruhr pocket described scenes of hopelessness. Bunkers once regarded as the safest places on the battlefield became symbols of impending death. Some troops abandoned positions before the first shell landed, refusing to wait for the collapse they had witnessed elsewhere. Others attempted to relocate communications equipment and heavy weapons into forest clearings or dispersed field shelters, an act that crippled their defensive organization. American units recognized the strategic value of this collapse in morale. The Black Dragons not only destroyed fortifications, but also accelerated breakthroughs. Infantry assaulted weakened lines, encountering fewer defenders willing to resist. Commanders noted fewer counterattacks, reduced German coordination, and an increasing trend of mass surrenders following artillery preparation. The culmination of these operations came during the encirclement of Army Group B in the Ruhr pocket. As pressure mounted, German forces withdrew into towns, factories, and fortified buildings, hoping their improvised defences would buy time. Observers directed fire onto specific structures, each shell landing with devastating precision. The speed of the collapse shocked senior German officers. In just 18 days, an army group that once numbered more than 400,000 surrendered. American intelligence attributed part of this rapid disintegration to the crushing psychological effect of the super-heavy guns. Through the destruction of the Siegfried Line and the fortresses of the Ruhr, the Black Dragon proved that fixed defences could no longer serve as Germany's shield. Soldiers stopped counting on walls and ceilings to preserve their lives. The weapon had not simply defeated fortifications, it had rewritten the meaning of defence on the modern battlefield. As the winter of 1944 gave way to the final months of the war, the Mine 1 240mm Howitzer had earned a reputation unmatched by any other ground-based gun in the American arsenal. Its presence on the battlefield had become a signal that a fortified position, regardless of its thickness or design, was already doomed. Yet behind this growing aura of invincibility stood a weapon that carried significant burdens. Logistical demands, mechanical complexity, and crew fatigue so intense that even hardened artillerymen spoke of the Black Dragon with equal parts awe and exhaustion. The paradox of the weapon became clear. It was both indispensable and extremely difficult to employ. And it was this very combination that shaped its final legacy. On paper, the limitations stood out immediately. No other field piece required such extensive emplacement work. Moving a Black Dragon across the muddy roads of Western Europe forced engineers to repair roads continuously, levelling ground before each repositioning. Heavy vehicles towing the split loads often struggled on narrow mountain paths or across temporary bridges. When the guns finally reached a firing position, crews spent hours digging recoil pits, assembling the carriage, and checking alignment. Even under ideal conditions, skilled teams rarely managed setup times under 4 hours. Once firing began, each round demanded coordination among more than a dozen crew members. The massive projectile had to be hoisted by crane, guided into the breach, and followed by carefully measured powder charges. The physical strain on the crews grew heavier as operations intensified. Many artillerymen rotated through roles to prevent exhaustion, yet the concussion from each shot still took its toll. Veterans later recalled feeling their entire bodies jolt whenever the gun roared. Prolonged exposure contributed to hearing damage that persisted long after the war. Powder handlers faced towering stacks of bagged charges weighing dozens of pounds each. Ammunition handlers repeatedly maneuvered shells heavier than an average man. Under wet, freezing, or muddy conditions, the task became even harder. Despite these difficulties, the Black Dragon's performance justified every ounce of effort. In the hands of skilled crews, supported by well-trained observers and efficient logistical networks, the weapon delivered precise, predictable devastation. Its value outweighed its burdens, and commanders understood that no other asset could match its ability to break fixed defenses. Even so, the Americans sought improvements throughout 1944 and 1945. Barrel life increased through better powder formulations. Mechanical fuse setters reduced the time required to prepare rounds. Standardized procedures cut emplacement times significantly. These refinements allowed the guns to contribute to multiple operations across increasingly diverse environments, from mountain passes to industrial districts to fortified river lines. The Rhine crossings, in March 1945, represented the last great showcase of American super-heavy artillery. As Allied armies prepared to breach Germany's final major natural barrier, planners recognized that the East Bank's fortifications needed to be neutralized quickly. Months of fighting had taught the Germans that bunkers were unreliable, but many still believed the defenses along the Rhine would delay the Allied advance. American commanders refused to take unnecessary risks. They positioned 12 Black Dragons as part of Montgomery's meticulous Operation Plunder bombardment. For 2 days, the guns fired in a rhythmic sequence that eliminated bunker after bunker along the Wessel fortified zone. Forward observers coordinated closely with air reconnaissance teams, marking each structure with precision. The impact on German morale proved devastating. Soldiers who had prepared to withstand hours of bombardment found themselves fighting inside collapsing structures. Entire platoons abandoned positions before the infantry even arrived. When American engineers secured the riverbank, they discovered that many bunkers had been so thoroughly destroyed that their outlines were barely visible beneath the rubble. These events underscored a growing realization. The Black Dragon did not need to be numerous to exert strategic influence. Only 315 guns were ever built. Yet their presence along critical sectors created profound effects. German commanders had to treat any fortified zone within potential range as vulnerable, even if the weapon was not actually deployed nearby. Psychological warfare emerged as one of the gun's most powerful contributions. Concrete, once the soldier's refuge, had become synonymous with death. German infantry accustomed to fighting from hardened shelters now hesitated before stepping inside. Engineers struggled to maintain defensive cohesion as soldiers dispersed into open positions rather than risk entombment. The shift in doctrine was so pronounced that German tactical manuals began instructing units to abandon fixed fortifications if super-heavy American artillery was present. Instead of reinforcing bunkers, troops were advised to relocate frequently, minimize time under overhead cover, and break into smaller, more mobile elements. The very foundation of German defensive strategy, which had been built over decades, had unraveled. The psychological scars endured far beyond the battlefield. German veterans later described overwhelming fear triggered by deep vibrations, thunder, or any loud concussive noise. Physicians in the 1950s documented clusters of trauma symptoms among former bunker crews, nightmares involving collapsing ceilings, claustrophobia, and panic attacks triggered by enclosed spaces. The phenomenon became known informally as bunker syndrome, a lingering testament to the terror wrought by the Black Dragon. The Americans, too, wrestled with the human cost of operating such a formidable weapon. Forward observers, those who adjusted fire from the front lines, suffered some of the highest casualty rates among artillery specialists. Their role required exposing themselves to enemy fire while observing bunkers moments before destruction. Many served hundreds of days in active combat zones, directing missions that erased entire German positions. These men bore the weight of what they witnessed, the instant transformation of fortified shelters into death traps. They carried memories of shattered concrete and crushed defenders well after victory had been secured. Yet the weapon's legacy extended beyond what it destroyed. Its existence influenced post-war military doctrine on both sides of the emerging Cold War. American planners recognized that super-heavy artillery remained relevant, but only if mobility and survivability improved. The Soviet Union studied the effects of the weapon closely, eventually developing the 2S-4 Tyulpan, a mobile 240mm mortar, inspired in part by the American success. Western militaries continued refining fire control systems, seeking even greater precision. In many ways, the Black Dragon's role in integrating forward observation, fire direction centers, and rapid calculation techniques laid groundwork for modern artillery doctrine, culminating in the eventual development of precision-guided munitions. Meanwhile, fortification design underwent a sweeping reconsideration. Military engineers concluded that traditional bunker systems could not withstand the combination of heavy shells, high-angle trajectories, and advanced fire control coordination. Fixed defenses gradually gave way to mobility, dispersion, and camouflage as the new foundations of survival, shifted their designs toward hardened field positions rather than permanent concrete structures. The age of the fortress, at least in its classical form, had ended. By the time Germany surrendered in May 1945, the Black Dragons had fired more than 118,000 rounds in the European theatre. Their confirmed destruction of more than 3,000 bunkers altered the course of multiple campaigns. Their influence reached far beyond the fronts on which they operated, instilling doubt and despair in the minds of defenders who had once trusted concrete more than anything else on the battlefield. The weapon's legacy ultimately lay in the transformation it forced upon the enemy. It demonstrated that no structure, however thick or carefully engineered, could guarantee safety. It humbled a military doctrine that had placed extraordinary faith in reinforced concrete, and it proved that industrial capacity combined with precise mathematics, disciplined crews, and a clear strategic purpose could overcome even the most elaborate fortifications. The Black Dragon did not win the war alone, but in battle after battle, from Anzio to Aachen, from Cassino to the Ruhr, it reshaped the very meaning of defense. The thunder of each round served not only as a signal of destruction, but also as a reminder of the extraordinary reach of American industrial and tactical evolution. In the end, the weapon's greatest impact was not the bunkers it shattered, but the certainty it destroyed. No German soldier standing inside a concrete fortification ever felt truly safe again. The walls built to protect them had become tombs waiting for a single, precisely calculated shot, and with each detonation, the Black Dragon announced that the last refuge of the German army, their concrete was no longer capable of saving them.